Hello, my name is Alexander Zhukov. I am a PhD student in Zaporizhzhia National University, and I'm here to present research about optimizing object detection performance through image enhancement for B images. Bees play a crucial role in maintaining the ecological balance of our planet. They are essential for pollination, which is required for the reproduction of many crops and plants. However, bees are facing many challenges that threaten their survival. Climate change, habitat loss, pesticide use, and disease contribute to the decline in bee populations worldwide. To address these threats, one promising approach is using neural networks to monitor bee health. Neural networks can provide real-time monitoring of bee behavior, detect changes that may indicate health problems, and accurately analyze large amounts of data. Also, detecting individual bee bodies can be used in future for spotting illnesses, wearer mites, detecting drones, or bee queen to monitor beehive state in general. But this process of bee identification on images is sensitive to the quality of data that neural network receives. Changes like time of the day, rain, general change in lighting condition may significantly impact the performance of the object detection model. So the aim of the study is to determine whether using image enhancement algorithms can lead to better object detection results. There are many studies conducted on the beehive monitoring using visual information. For example, CNN-based identification of honeybees infection using augmentation. This research proposed model combines an image enhancement method CLAHE, data augmentation method DC-GAN, and optimized CNN to classify infected or healthy bees from standard bee images. The results show that the CLAHE method improves sharpness and positively affects the CNN performance. In other paper, authors proposed a bee health identification methodology based on CNN and image filters that helps to highlight specific features on a bee image. Another research which set to determine the effects of data augmentation on the CNN-based identification of bee infection. Authors successfully used CLAHE to enhance the contrast on foggy bee images, which made them more understandable and led to better CNN classification results. There is also a study on honeycomb detection and classification using deep learning, and it also showed positive results when using CLAHE, as it allowed honeycomb edges to be much more distinctful. As a data source for the dataset, photos of beehive sections with bees on them were used. Those images were manually annotated and then split into training and test sets that will be used for model training, and evaluation set which will be used for manual review of model's performance. For the training, two image enhancement techniques were picked: histogram equalization, contrast limited adaptive histogram equalization, or CLAHE in short. Along with them, another model was trained using protobuf pipeline data augmentation features, which allowed to apply changes like hue adjustment, saturation adjustment, and contrast adjustment to random images on a training stage. Examples of using histogram equalization and CLAHE you can see at the bottom part of the slide. On the given examples, we see that both changed the image in their own way histogram equalization made the image brighter, and Klahe managed to highlight more details that were not visible on the original images. Before training, each image enhancement was applied to the dataset and a model was trained accordingly. Since they are using the same object detection model, learning graphs look pretty much similar. For the model, an SSD mobile net architecture was picked since it showed good results in similar tasks of BIS detection in another studies. For the purpose of changing lighting environment and images defect simulation, another evaluation set was created. It is based on the initial one, but has randomly altered brightness and saturation. Based on the initial performance validation on the base evaluation set, applying image enhancements didn't increase the end recall and precision results. On the other hand, even though dataset with Klahe algorithm applied didn't show the best result, its precision and recall are similar to the original dataset. Next, the performance on a corrupt dataset was reviewed, and here we can see that Klahe-based model showed the best results on the unstable data, both in general and blurred version. Other models didn't show significant results in this experiment. The main goal of the current study was to determine whether using image enhancement algorithm can lead to better object detection results, and the results of this investigation show that using histogram equalization and Klahe algorithms have not increased the precision of the object detection model in general. But another major finding is that usage of Klahe algorithm may lead to more stable results in various lighting conditions and small defects in image coloring. However, using histogram equalization, blur, and data augmentation features of protobuf's pipeline did not show significant results in either test. Thank you for your attention.